Look, it looks messy. Not every point's expanded. Some things in there are wrong. But it's damn good. And it's much better than if I'd left the lecture notes just as bullet points. So well done to everyone who did that last week. Everyone knows they're doing a different week. Who's doing this week, week 2? Put up your hands if you're in the week 2 tutorial. I should be seeing 16 hands going up. Okay, yeah, well look, that's close to 16. That's reasonably good. Well done, guys. Now, from you, we expect a much higher standard than the first week guys, because we didn't have the first week guys' notes to look at. The notes you write today in your raw notes should be a reasonable summary of everything we say. So if already I've talked for, 10 minutes and I've said nothing and I'm not talking about anything in the lecture notes, and there's no bullet points corresponding to what I've said, but I would expect to see when I looked at the raw notes that there'd be a discussion of fence post errors, that some examples would be given that were the examples in class, there would be some discussion about wiki notes and so on and so on. So hopefully you're writing all these raw notes down and you're going to put them up. That's really good. Now, I looked at last week's notes and some people in that shoot didn't put anything up at all. So you'll have to negotiate with your tutor, who I think is Rupert, as to whether he lets you write notes another week or he lets you retrospectively write those notes and get the mark, or whether you just lose the mark. Because we expect everyone to contribute, and it's a reasonable amount of work. We expect you to put like an hour or 2 into the thing when it's your week for the raw notes. Look, these notes here are pretty good, and I was really pleased. And some people put a lot of effort into them, and they hadn't seen any raw notes before. They hadn't edited on a wiki before. They were doing it all from scratch, and they just dived in and did it. And well done. So I was really proud when I saw these notes. Well done, guys. But as I said, this week, hopefully it'll look neater. This does look a bit messy, doesn't it? You wouldn't expect to see a page on Wikipedia that looked like this. There's lots of good information, but it appears to all be in one paragraph. So yeah, okay. So from a style point of view, how would you adjust that paragraph to make it more pleasant to read? Add white space. Yeah, is that what you were going to say? You were putting your hand up, not shouting out. Thank you very much. Split it into more paragraphs, so break it into logical units. If you're splitting it into paragraphs, what should each paragraph do? Each paragraph should do its own thing, one idea per paragraph. So if you've got 3 ideas, how many paragraphs would you expect to have? 7. You'd expect 3. Yeah. 7's close, but no. Yes? You want to emphasize headings. You want to give it some sort of structure. You want to give clues as to where you're going and all that sort of stuff. Yeah, yeah. We call that style. The same information's there no matter how you organise it, but with good style, you organise the information in such a way that it's much clearer and easier to see about what's going on. So style's important for all sorts of communication, certainly when you write wiki notes, but more especially, I mean, you can probably see who can see what I'm really trying to say? What am I really trying to say? Yes? That it looks messier? It does look messy, yeah, and say it a bit more? More time should have been taken. Yeah, yeah, I agree. But I don't want to diss them because they, were doing it in the first week and everything. So it's you, so it's okay. Well done. So you did well. Yes? It's hard to read. It's hard to read? Yeah, yeah. So there's like this subtle point I'm trying to make though. Can anyone see the subtle point? I can bring it up in the next lecture if no one's got it. Yeah. When you write your programs. Yeah, yeah, yeah. What were you going to say? Same thing. Yeah, explain what I was going to say.
When you write programs, you should leave white space and comments.
When you write a program, it's an exercise in communication, and you need to have good style, which means you need to set it out neatly so it's clear to read and so the ideas spring forward. You should basically arrange it in chunks, so there's one idea in each chunk. You should put white space in to separate things from each other. And a program works just as well. The computer completely ignores new lines and completely ignores spaces, except it needs one space between words, but more than that it ignores. So you could write your whole program in a big mush like this paragraph here. And as far as the computer's concerned, that's a completely legal program. But as far as we in the course are concerned, what do we think of that as a C program? Yeah, it's not good. It's not good. It might be correct and it might work, but no one else reading it will understand what it's doing. It's very confusing. It hides what it's doing. And we never want to hide stuff. And I'll tell you why we never want to hide stuff in the second lecture today. Okay, let's now jump back to the lecture. So design with functions. Gee, there's not many notes here. What's going on? Why can't I see many notes for today's lecture? Because I'm looking at the nice notes. Yeah, yeah, yeah. And no one's written any nice notes yet. The only nice notes that were in there is wiki notes. Who's doing it this week? We found out. Review and assess the notes from last week. Well, we've done that. But actually, what notes do I want to be looking at? Okay, Richard's bullet point notes. Here we go. All right, design with function. Mike Teng, are you here? Wave your hand at me. Yeah, can you come and see me after in the break? There's nothing serious, just need to talk to you. Saver Plus, I just got an email from the Equity and Diversity Unit about something called Saver Plus. It seems so cool that I really wanted to mention it in the lecture, but if anyone here has a pension card or any sort of government concession card at all, it appears you can get the government to give you $1,000 by just clicking on this link. So please do that if you have any sort of, or you think you have any chance of getting $1,000 from the government, click on this link and it'll tell you all about it. Wiki notes, we've done that. All right, now we're going to start talking about the C language. It's very hot and humid in here. Who thinks that? It's very, very hot. I don't know how to solve that. Definitely the air conditioning is on. Who feels hot? Who doesn't feel hot? Oh, that's weird. Okay. I thought maybe there'd be people at the back feeling hotter than people down the front. What if I prop the doors open and we've got a breeze through? Would that be good? Bad for air conditioning. Why are you shaking your head? The air conditioner is on in the sense that the light's on there. You're not going to cool the whole earth, it's not going to work? I don't know, but if the air conditioner isn't working, maybe I could turn the air conditioner off and open the door. What's that? I'd need to open a whole sequence of doors. Yeah, that's right. Like if I've got doors, here's the lecture theatre, and there's a door to the lecture theatre there and there, and then outside there's a series of doors here. Do I have to open both of these doors or just one? I have to open just one, so it's either I have to open this or that. But once I've opened this, do I have to open that or that? But I could get away with just opening one. Either will give us an airflow, but I have to do that and I have to do that. Does that make sense? Yeah. That's why the room's so hot, because the class in here weren't computer scientists before and they didn't have our deep understanding of and or. So shall I try opening the doors? Let's have a vote. If you think I should open the doors, put your hand up.
Don't they have those automatic closing thingies?
Well, we'll find out in a second. And if you don't think I should open the door, put your hand up. Oh, okay. I'm going to open the doors. Lodge a protest, yes? I'll just open one. Okay. Thank you for that, guys. So let's start writing some programs now. Start. What program am I going to use to write a program? Up until now, you've all written your C programs using Pico. Pico is a really annoying editor. You've probably discovered that. Why did we teach you Pico first? Because, put your hand up if you think you know why we did Pico first. Yes? You can use it from home. Any other editors you can't use from home, so you're stuffed. So now you know Pico, you're in, or Vi, yeah, okay. You're stuffed before you start with Vi. Okay. So we're going to use Pico. Don't worry, if you don't know Vi, that you're in a good position. So we started with Pico because you need to use it from home. But if you had a choice, would you use Pico? Yes. No way. Oh, well, yes, if you like it. But better to use a better editor. And you've probably seen NEdit in the labs or something like that. If your tutors said, oh, actually, you could use another editor. This week in the labs, we'll use a different editor. But remember, you can always use Pico if you have to connect in from home. So today, I'm going to use a better editor. And I'm going to use... Oh, no, I won't. I'll use Pico one more time. No, just for old time's sake. No, because the other one would mean I have to switch to my Mac. And as you know, I don't like Macs. So I'm going to log in. I'm going to log in as me, which is CS1917. And I'm going to type in my password, which is... There we are, we're in. And I'm going to go to... what did I call it? Does anyone remember? Let's go to public. Was I call it chicken? I don't think I call it chicken. Lectures. Lectures. Here we are. Thank you very much. So I'm in the lectures directory, which you can now access on the web as well. I'll put a link in today's lecture notes so you can see all the code I'm typing. And let me open another window, one for editing. Oh, and one. Can I what? Oh, the lights came on again. All right, and I'm logging in as me again, CS1917. And I'm typing that password. And I'm going into public HTML. And I'm going into lectures. And I'm going to make it bigger for you so you can read it.
Oh, yes.
That'll do, that's all right. And the other one is, you know what, why don't we change the colour in the background so you can see default background. Let's modify the background colour. Whoa, hey, hey. What about that colour? Oh. Is that good at the back? Can you see that? Yep. All right, so now you know when I'm in one or the other, you see? Isn't that convenient? All right, we're going to say that the attractive black and white one is where we're going to write our program. So we're going to go Pico, and we're going to write a new program. We're going to call it week2.c. We're going to write a new C program. Now, how do I always start my C programs? With a comment. And the comment should say, what the program does. So week 2 sample lecture code. And the comment should say who wrote it, by Richard Buckland. And it should say when I wrote it, which is today's date. Does anyone know what that is? 17th of March 2008. And then I'm going to start writing my program, and I'm going to do some IO. Well, let's suppose I don't do IO. I'm going to start by saying int main. Now, I told you last week you had to believe what was happening here. This week I'm going to explain what's happening. The word int, does anyone remember what that means? Yeah, it stands for the word integer. This means what I'm going to do now is something that's going to be a function. I'm going to write a function now, something called a function. And that function is going to do some work. And when it's finished doing its work, it's going to give us back an answer. And that answer will be an integer. Yeah. So if you were a function, say, and you were a cook, I could give you a whole lot of ingredients, and I could give you a recipe, and you will return to me a cake. My favourite sort of cook. So that would be a function of type cake. Yeah, it returns some sort of cake. You put in ingredients and recipe, it returns cake. And if you were a builder, I could give you some house plans, and I could give you some bricks and mortar and all sorts of stuff, and you would return to me a house. Well done. Okay, so you'd be a function. Function takes in stuff, does something with it, and returns something, and you'd be a function of type building. You'd return some sort of building to me. Let's see, can anyone think of another function in everyday life? Money. No, money's a thing. An investment. Yeah, okay. The share market. You put a whole lot of money in. No, a stockbroker. Okay, you're a stockbroker. Here we go. Stockbroker, you give them lots of money. You don't give them anything else, do you? You just give them lots of money, and they give you back a postcard from the Bahamas. Yeah. That's of type disappointment. Okay, so yeah, that would be a function that takes in some money and returns some money. Okay, possibly. Yeah, maybe money. Okay, so we're going to write a function. What's our function called? Can anyone guess? Main. Okay, we're calling the function main, and it's going to return an int, which is a number. Now, we've got to tell the function what's going into the function. Remember, a function is something you give it something, and it gives you something back. What are we going to give it? We're going to give it two things. We're going to give it an int called argc. It's a pirate sort of thing. Yeah. Argc, and we're going to give it a char star. You don't know what that is yet. called argv bracket bracket. What does that mean? That's a fancy thing we're giving it. We'll tell you about that later on. Now, when I say we're giving it, this is our whole program. So we don't give it anything. Every C program consists of functions. And you write a function, and your function to solve the problem might use another function. Like, for example, in the middle of building my house, you might need a delicious cake. So the builder function may well call the chef function. The builder function might be in the middle of building. Well, the stockbroker function. Okay. You're my stockbroker. I give you all my money. Straight away, you start building yourself a house. You give the builder so much money that he decides to make a cake every day. So you call this function 500 times, and every time you get a cake back. You eventually finish the house and you give it to the stockbroker, and he gives me postcard from the Bahamas. Yeah. Okay. So a function can call other functions, and that's all C programs are. There is a series of functions, each function possibly calling other functions to do stuff. And the top function of all, the function that runs everything, is called main. That's right. So if main is the top function of the whole thing, then who calls main? The operating system. Windows or the Mac or Linux or something like that. So when you write a program, they're eventually going to run your program. That means they call the main function. And when they call the main function, they give it some information. We're not giving it information, the operating system's giving it the information. That's what these things up here are, the information the operating system's giving it. I'm going to be slightly vague about what the operating system's giving it at the moment, but when the function's finished, it has to return a value to the operating system. What sort of value does it have to return? It has to return an int, that's right.
So could we put return 6?
You could return 6. Okay. Well, what have I done wrong? Oh yeah, I haven't indented it right. Thank you very much. I only indented it 2. That wasn't very good. Okay, so this is our function. Now suppose this function, let's just do some stuff. Suppose I wanted to print out, this will all work now. Let's just compile it and just check it works. It's a pretty boring function. It might confuse the operating system because we're giving it 6. Did I exit then? I didn't mean to exit. Let me just go back into there. I just saved it. That's the main thing. Let's go and now run it. And we go dot, oh no, we have to compile it first, which is gcc negative wall negative o, oh, negative where? Okay, I like your strictness, guys. I like where, it's a good one. Negative o, what are we going to call it? What's a sensible name for today's lecture? Week 2? Week 2 demo? Not 8 not out. 8 not out means nothing. It's very hard to think of a sensible name for this program because suddenly the program doesn't do anything. The name should reflect what the program does. Yeah, could call it waste of time, but I'm hoping it's not going to be a waste of time. Let's call it a week 2 demo because it clearly is a demo in week 2. So the name does contain some information. And I'm going to compile the program that we just wrote then, W2C. It's going to run, no errors, that's slightly alarming. And now we're going to compile, now we're going to run it. We've compiled it. Let's just run it. And it ran. And it did everything we asked it to do, which was nothing. Okay. It looks suspiciously like a builder function, doesn't it? Okay, let's go. All right, now let's get it to do some actual stuff. Programs are only interesting if they take in some input and give us some output, if they do some I/O. So let's tell it, what's it going to print? Print. Well, let's just, oh, actually, before we even do this, I don't want to lose my typing, but I don't want to do this, so I'm just going to comment that out. My typing is saved. Instead of returning 6, let's just go back to where we were. Let's just go back. Okay, so we'll leave the program exactly like it was before. It's got one more comment now, but the computer's going to ignore that because it's a comment. What would happen if I compiled the program, but I forgot to say negative O? Well, if I forgot to put any of that. Oh, no, let's just... I'm going to one by one leave the things out and let's see what happens. So first of all, let's leave out negative O week 2 demo. What's going to happen? It made a program, but what's it called it? There's a command called ls, which prints, ls stands for list. This is a Unix command. Now, how they invented commands in Unix was they thought of a really descriptive word that described exactly what the program was doing, and then they removed all the vowels from it and all the other important letters that gave you a clue as to what that word was. So ls means list. Yeah. Unix was sort of designed by people, these days we'd probably call hackers. And I don't mean hackers in the sense that they're really cool ninjas who break into things electronically. I mean, they're hackers in the sense that they write programs by just, you'll know what a hacker is when you meet a hacker. In the old days, it was a word that was a complementary word. And certainly the people that wrote Linux and Unix, we really think they're awesome, so we're complimentary of them. But if they tried to write Linux these days, we'd go, phew, that's not so good. They didn't know in the old days. A hacker is, let me give you an example of a hacker. Suppose you are a hacker, and suppose you are an elite programmer. And I'm saying, guys, here's task one. Task one has something to do with software piracy. Go and do task one. Go and do task one. They're doing it. Elite hacker gives me the program back that he's written. And I say, thank you. You're not elite hacker. You're
Regular hacker.
regular hacker. Oh, now I'm confused. Sorry, guys. He was just plain hacker, wasn't he? And he was just plain... Oh, you're elite programmer. So there is no elite hacker. That was like that was an ant. That was not good. Okay. So hacker gives me his program and I read it and I go, wow, that's awesome. That is so clever. You must be really smart. I can't understand this at all. That is so clever. And I sat down for an hour and I worked out what you were doing here. Oh, that was brilliant. And you squished it into 3 lines. A normal person would have taken like a page to say that, and you just squished it down so much. And it was really hard to understand. I'm not fully sure I still understand it, but it's very clear to me you are an extremely clever person. And that problem was much harder than I'd realized. And now I feel very guilty that I handed out task 1, and it was such a hard task 1. I'm very sorry. And then I come over here and I mark elite programmer's code, and I pick it up and go, is that it? Well, it's sort of obvious, isn't it? I thought task 1 was hard. Now I think about it, task 1 was really just an obvious task, and this is quite trivial, and I guess anyone could have written that. That's fantastic. A fantastic programmer writes a program which is so clear and follows the problem so exactly and maps onto the problem domain so perfectly that when you read it, it all just seems natural and effortless. And you just think, yeah, okay, of course, so what? Yeah, obvious, yeah. And you hand it back and you think he's not very smart, he's not very good, the problem wasn't really very hard, it was a trivial problem, anyone could have solved it. An elite person, a hackery person, is trying to show you how smart and clever they are, and they're making it obscure and convoluted, and they're not understanding it exactly, and they're putting in patches on, and this almost works, and if I just nail in a little hole here, that's yuck. And I used to do lighting for plays, and it was exactly the same. At the end of a play, I realized after years and years of doing theatrical lighting, the best compliment anyone could give me after the play was if they came up to me and afterwards and said, oh, what were you doing here, Richard? I didn't know you were involved with the play. If I said, oh, I did the lights. If they said, oh, those lights were fantastic, all those effects and that flashing, that was awesome, well done, they were super excellent lights. Then I thought, oh, damn. But if they said lights, were there lights there? I didn't see it. Well, that's nice. Then I think, oh, I did it well. You did it. I did it so well, I made myself redundant. The lighting seemed so natural. It created the scene so perfectly. No one was even aware that I was doing lighting. It just seemed exactly what everyone expected. So if people notice it and it's flashy and show-offy, it's actually not so good. So what we want to strive for in our programming is finding the simplicity hiding in every problem and revealing that through our code. Because inside every complex problem, I believe every complex problem is just a simple problem looked at from the wrong angle. Every problem has a simplicity in it, and the art of being a really cool programmer is like you find that simplicity and you bring it out. And everyone looking at it, you're doing yourself a disservice. Only other programmers realize what an awesome job you've done. To everyone else, it's nothing flash. So the people that wrote Unix, ls, no one knows ls. If you wanted to list the files in the directory and you had to guess what command to type, you could never guess ls. So you're a bit of a guru if you know this command. It's a bit of a show-offy thing because it's a way of establishing your knowledge and things. So it's actually a bad way of naming the command. But let's just ls and look at the files in the directory. There's something called w2.c. There's something called w2demo, which is a program we made before, and there's something called a.out. How did that get there? Well, the C compiler, if you don't tell it what you want to call your program, it says, oh, he probably wants to call it a.out. So a.out isn't such a good name. So let's remove that. A.out. RM means, of course, remove. And I was going to jokingly show you a command that would zap your disk, but I won't even put it down as a joke because someone will write it as a note. And yeah. So RM means remove. It's a dangerous command to use, so be careful. All right, so we left out one command. Let's leave out some other ones. If I want to leave out, I'm going to create that, but I leave out the W2W error. What happens differently? Nothing. Warnings aren't treated as errors, but if I don't have any warnings, it doesn't make any difference. If I leave out wall, what difference does it make? Nothing. It all still works, and you'll notice that program's still there. It's made of the program. I can run it if you want. Does nothing still, but it's there. If you leave out the wall and the whereer, it just removes a whole lot of checking from the program. But everything will still appear to work. So you have no idea that you've pulled those warnings out. But you're like driving a car. You're like in a submarine. And the submarine has an alarm that goes off when you're running out of oxygen. And you think, I don't need that alarm. And you take it out of the submarine. When you're on the submarine and everyone's okay and there's lots of oxygen, you don't notice the alarm's not even there. Okay. The only time you notice it is when it's too late. So just get in the habit of always putting these warnings in. Hopefully you'll never need them. But if anything ever goes wrong, it'll tell you there's some potential problem. All right, so we're going back to our program. There's all our compiling stuff. Let's put some stuff in the program now. I'm going to make, oh, that wasn't indented right. I'm going to print something out. Print out W2 demo so we know where we are. I'm going to put a new line in at the end. Otherwise, sometimes it doesn't print out for a while, and that's annoying. I want to see it straight away. And now if I'm going to print out IO, what do I have to put up here? Hash include to put all the IO stuff in so it knows how to find the printf function. Printf is in fact a function. It's a function. What goes into the function? A string in this case, some letters and numbers and things, some symbols, characters. What does it return?
Nothing.
It returns nothing. It doesn't actually give anything back, but it has something we call a side effect. It prints something on the screen. It's like the cook. Suppose you love singing. So I go to the cook and I give the cook all my ingredients. And the cook sings a happy song and gives me back the cake. And here's another cook. I give you the ingredients. You're just an angry cook. So you shout a lot and you give me back the cake. It's the same cake. It tastes the same. As far as from a functional point of view, I only care about what the input and the output is. I gave you the same ingredients. I got the same cake back. I don't really care whether you're happy or sad when you're making it. I just care about the input and the output. It's like the business world. But there are side effects of functions. Sometimes other things happen. And a side effect in this case was I got to hear beautiful music or I got to hear interesting curse words. So printf is a function that only has side effects. It prints something on the screen, it's like singing a song, but it doesn't actually return any values. It doesn't do anything we can make use of. Scanf, on the other hand, oh no, scanf's not a good example. Let's write some other functions. So let's say I'm going to create a variable. What am I going to call my variable? Not chickens, this is like, I'm going to, dollars, what about dollars? Okay, so I'm going to write a function that is going to say printf how many dollars do you have? And then I'm going to read in a value into dollars. How do I do that? Scanf %d, oh, %d, dollars. What did I do? Oh, thank you very much. Without the ampersand, that would be crazy. Wonder what would happen if I didn't put the ampersand in there. Try it and see. Okay, let's run it without putting the ampersand in. Let's see what happens. It's going to be weird. Let's see. Ah, it gives us a warning. %d expects an int star, but argument has type int. It's a cryptic warning, but at least it's giving us the right line number. What line is the error on? Line number 9. It's actually telling us the right line, so that's a convenient thing. So there's a problem. What happens if I turn warnings off? I wonder if I'll still get that message. Oh. My incorrect program has not been detected. So that's a problem. Hey, I wonder what it does when you run it. Let's actually make it. So we've made that program. It's called W2 demo, but now it's an incorrect program. Let's see what it's going to do. Because whatever happens, it can't do anything bad. Because I don't own this machine. It can't do anything bad. How many dollars do you have? Oh, I don't know, 45. Segmentation fault. Awesome, we've got a segmentation fault early. You'll see segmentation faults are something we cherish in this course. So we got an error, there's something wrong with the program, and you know what the annoying thing is? You'd go back and look at that program forever and you'd never see the mistake. Because once you forgot to put the ampersand in, every time you read it, you'll sort of forget to see that it's there. Once you've made an error, it's very hard to see it. So hot tip number 1 from Richard. When you make an error and you just can't track it down, I advise taking a break and going for a walk. Because if you come back with new, fresh eyes, you'll spot the mistakes you've made. Otherwise, you'll keep reading it and glancing over the mistakes you've already made. And hot tip number 2, if you make an error and you can't see it, what should you do? Show it to someone else. Yeah. A fresh pair of eyes. Your lab partner, the person sitting next to you in the lab is great. If you're working in group work, show it to someone else in your group, show it to your tutor, show it to your mum, show it to anyone, because there might be something really obvious that you just can't see because you missed it the first time. It's like the elephant in the room. Yes?
What does the ampersand do?
Well, the ampersand, remember I said that's a magic sauce. I can't tell you what it does yet. We're so close to being able to tell you. Well, I can tell you vaguely what it does. Vaguely what it does, it means this variable is going to have its value changed by the function. The function's actually going to modify this variable. But there's a real reason for what's going on there that will all become clear once I explain what ampersand really means. But we don't get to that for another week or two. So all right, so we've read in the number of dollars. And now I want to pass it to Macquarie Bank. Because we love Macquarie Bank. What are Macquarie Bank really good at doing? Making lots of money. Improving the world, improving the environment, helping people, and distributing love. And along the way, making lots of money, mainly for Macquarie Bank. Yeah, okay. So let's suppose we give our money to Macquarie Bank. And look, if anyone here works for Macquarie Bank, I'm really, really sorry. I don't mean to insult. Or your dad works for Macquarie Bank, or anything like that. I'm really sorry. Some of my students have gone and work at Macquarie Bank now. Okay, so let's say we've got Macquarie Bank comes along and they're going to modify the amount of money you've got. How are they going to do that? Divide it by 2. Okay. No, that would be cruel. Let's say dollars equals dollars divided by, that's a funny way of doing divided by. We haven't got a key that's a divide symbol, so it's that slash divide. Divided by 2. And let's print out, you now have %D. Oh, let's put a dollar sign in there. What did they say? Glad to be of service or something like that? What's good for M&M Enterprises? Something like that. Glad to be of service. Thank you, come again. Yeah. Okay, there we go. So here's and now look, here's a problem with Pico. It wraps around, and when it's wrapped around, it's put an actual line in. I've got to delete backwards to go back there. It's very annoying. Okay, I forgot to give it, I've got to give it the number that I want it to display, and that's dollars. So notice the line above the line, where I am now, has actually modified the number of dollars. It's taken the variable called dollars, which is an integer, it's divided it by 2, and now it prints out the modified version. I shouldn't return 6, by the way. I'm supposed to return 0. Let me just return, that's an O. Let me return 0 for a moment. Later on we'll see why. I keep hating all this later on stuff. Later on isn't very long. Within a week or two we'll have done all this later on stuff. Can anyone see a program in that? Why is there a dollar? Oh, because it's dollars.
No, because it goes to the end of the, goes past the end of the line.
Oh, there was a dollar there. Okay. All right. Let's just compile it. Oh, yeah, that's my editor window. Thank you. It's the wrong color. The compiling has this attractive background. O undeclared. First use in a function. Line 13. Let's go and look at line 13. Return. Oh, that was a capital O. I changed it to. O looks like 0. It's very annoying. And we only invented 0 recently. The pirates didn't have a 0, for example, in the old days. Wrong window. Yep, thank you very much. See, I've got lots of eyes to help me here. That's really cool. We've compiled it. Now let's run it. How many dollars do you have? I have $100. You now have $50. Glad to be of service. Okay, so it's a cool program. What would happen if I hadn't typed in an even number? Try it and see. Have a guess at what's going to happen, guys. Have a guess. I don't want anyone to call it out. I want you to guess. Shh. No, I just said I didn't want anyone to call it out. Oh, man, you're going to have problems with the assignment spec. Because the assignment spec, when I give it out, the assignment spec is going to say do this. And what do you think we want you to do? Yeah, no, not that. This. Yeah. And it's like I'm a really literal dad with my kids, and they'll say things like, Gwen will say, "Oh, Dad, can you put my dress on?" And I'll go, "No, it's too small." And she'll be standing there with the dress in her. She says, "Oh, me!" And I go, "Oh, okay, sorry, Gwen." It's very, very literal, and we're all like that. We're just a bit weird about being literal. So if the spec says do this, we want you to do this. Now, some of you are going to come and say, "Well, I handed my program in. I know you said do this, but I thought it would be heaps better if the assignment did this instead." So I made mine do that. And what's going to happen? Zero. Yeah, that number that Vikings didn't know about. Zero. I mean, not zero exactly, but you've got to follow it. And you'll say, "But I think it should do this." And we'll say, "That's interesting." But that's all we can say. Because when you get a spec, which is a description of a problem, as a programmer, you have to do what the spec says. If you don't like the spec, you're free to rant about the spec and grumble about the spec. And that's part of the job of being a programmer. We're always grumbling, saying, "Hey, the spec's stupid, man." But you still have to do the spec. Does that make sense? So, yeah. So listen really carefully to the spec and see what it says, because you've got to do exactly that, because we're really pedantic. We won't give you 0, but you certainly won't get full marks if you don't follow the spec. And in second year, it's 0. I mean, first year we're sort of more gentle. In second year, it's just, we asked you to do this, you didn't. But I didn't. No, you didn't. But I, no, you didn't. That's it. You now have $49. Glad to be of service. It appears to have rounded it down. It didn't display it as a fraction or a decimal. Why not? Because it's stored in something called dollars, and that's an int, so that can ever only store whole numbers. And when we printed it out, we used %d, which means only print whole numbers. So it had two things forcing it to be a whole number. It had to either round up or round down. It rounded down. And in general, slash sign, when applied to integers, does rounding down. In fact, the complement of that is, I'm just about to recompile it. The complement of that is the percent operation. I could say GST rounding error equals dollars percent to. Now I better define what GST, let me say int GST rounding error. Thank you very much. So I've created a variable called GST rounding error, and it's dollars percent to. Now let me just line these up so it's really clear what's happening here. I want them to look exactly the same. And let's GST rounding error. Now look, this line is so long now, it's way too long. Lines should never be that long. If it gets really long, just put a new line in and space it out sensibly. Don't want your lines to be so long they go off the edge of the screen. That's no good. Oh, that's amusing, $1 at the end of $. There we go. Let's do that. That looks nicer. Remember, the computer more or less ignores new lines. Okay. You now have %d %2 is %d. I want to put a percent sign in here, but this percent has a special meaning. How am I going to actually put a special percent in? 2%. I have to go %%, because just 1%, it thinks I'm going to type %d or %s or something else. So %% means percent. So if you wanted to say %%, what would you have to say? %%. Okay. Glad to be of service. And let's go dollars. Okay, so this is going to print out dollars %2 is whatever. Okay, let's run it. How many dollars do you have? I have 99. You now have 49. Glad to be of service. 49 %2 is, Oh, that's sort of okay. Okay, 49% 2 is 1. I'm just lucky. Percent, when you do the slash, it tells you the whole number of times it goes in. And when you do the percent, it tells you what the remainder is. That was my long, elaborate way of saying that. So if I was to say 12/5, what would the answer be? 2, because there are 2 5s in 12. And what's the remainder? So if I was to say 12% 5, the answer would be 2. All right, let's pick a better example that has different answers for those two things. What about if I said 21% 6? I hope this is going to work. How many times does 6 go into 21? 3. As an infant school, you'd go 3, remainder 3. Oh! 22 and 6. All right. So 22 / 6 is 3 because 6 goes into 22 3 times, remainder 4. So 22% 6 is 4. Does everyone get that? Yeah. Oh, look, there's lots of yawns. Let's take a break. Okay, so we're going to take a quick break and we'll resume in 5 or 10 minutes. Okay, go. I'll put the other one up for you to look at while we're doing that. Hi, you're enrolled in 917, this course,
Yeah.
and Comp 0011 as well?
Yes.
Now, under the rules of your degree, you're only allowed doing Comp Eng, Comp Sci?
Comp science.
Comp Sci, yeah. I don't even know why the system let you enroll in it. It was crazy. So it's not your fault. I'm sure you weren't to know about it. But it would be terrible if you got to the end of this semester, because then you'd find out you've done this course that will never be counted. Do you think you'll be able to find another course and flip or something like that?
That's right, yeah. Because I was looking around for the other courses and stuff, but
Yeah.
most of them, like, they had a timetable clash.
Are you doing Eng 1000?
No. But that had a timetable clash as well.
Oh, what was the clash with? Was it a lecture clash?
I think so, yeah. So,
After the lecture,
yeah.
go to the office, the school office, and if, I mean, they might help you. They're probably busy, but they might help you find something else. There might be a way of getting you in even with a clash. So after the lecture, go to the office. I'll come with you. You'll get there before me because it takes me about half an hour to pack up all the gear. But I'll come in, if you're still at the desk talking to them, I'll come and join in too.
Whereabouts is that?
The school office is in the ground floor of the K17 building. Yeah. But because, it would be terrible to get to the end and find that out. Eng 1000 would be a really cool course for you if you're able to do it.
Thank you.
Yeah.
Richard, is it
Hello,
Rob?
yeah. Hi.
I just joined in this course
Yes,
today, so
yes.
I'm a bit lost.
Oh yeah, well you will be for a little while, but luckily we made videos of last week's lectures. You'll be able to watch
cool,
them.
cool.
So desperately get last week's note. Are you friends with anyone in here?
Yes, I am. I've missed
notes from them.
Lab Zero
Yeah.
as well, so I don't have an account to
Yes.
log in.
Oh, okay.
So,
What were you doing before? Nothing?
I just changed into this course.
From?
Because I was doing com law, I changed to science and law.
Oh, okay. So you weren't doing any computing before?
No.
Who's your tutor? Do you know?
I have no idea.
When is your
tute?
tute?
The tute yet. It's
What?
tomorrow.
Yes.
It's tomorrow afternoon.
All right. I would try and do Lab Zero first, desperately.
Okay.
Mail me, which is Richard B at CSE, and tell me your full name, and I'll give you a wiki account and thing straight away so you can get on the wiki and start seeing the material.
Okay, so I can get to the wiki like online from home?
Yes, you can from anywhere. Yeah. Just from the homepage for the course.
Okay,
something- yeah,
so
yeah.
it's not actually on Vista.
No, we don't do anything on Vista.
Okay.
Yeah.
okay.
So just go to that one course homepage.
Yeah, because I was a bit lost. I was trying to like read up last week's stuff, but it wasn't on Vista, so I had no idea.
No. So there's just one URL, and ask the person you're sitting next to or your friend, and they should be able to tell you the URL. You go to that thing, and there's something called schedule. Click on that, and it'll show you everything, including Lab Zero.
Yep.
And have a real good try at doing that before the lab. If you do it in the lab, it's fine, and the lab guy will help you. But then you'll be behind because you should really spend that lab trying to do the lab exercise.